We're now going to start learning some physics. So our first note is called simple motion. And there's two kinds of quantities that we're going to deal with. We have scalar quantities and vector quantities. And the big difference between the two of them is a vector quantity, we care about what direction we're going in. So direction is important with a vector quantity. So let's start scalar. So a scalar is a measurement with only magnitude. Magnitude is a number. It's what the size is. And we always associate units with numbers. So for example, time is equal to 3 seconds. So it has a measurement, which is a magnitude, which is 3, and we write down units. A vector quantity is a measurement with both magnitude and direction. So it has size and direction. An example of this is something we call displacement. So displacement is 100 meters east. So this time we've put a direction in. There's a couple little symbols I want you to pay attention to. So when we have vector quantities, above the symbol, we put this little half arrow. So it's a line and it hooks back a little bit. The other thing is the direction itself, we put in square brackets. And the direction could be anything. It could be like north, south, east, west. It can be up, down, left, right, forward, backward. Anything, those things work as a direction. So scalar quantity, it just has a number with the units. There's no direction. And some things can only be scalar, like time. You never say 3 seconds down or 3 seconds left. Another example would be mass. So 3 kilograms, there's never a direction. So you never say 3 kilograms north. Okay, it's just 3 kilograms. However, our distances could be both. So if you just see 100 meters, we know that's a scalar quantity. But if it's 100 meters east, it has a direction, that's a vector quantity. So big difference. Scalar, no direction. Vector has a direction. Let's keep going. I've been throwing these two names out. So one is distance, and the symbol for distance is d. And the other one's displacement. The symbol for displacement is still a d, except we put this little half arrow on top. As soon as we see that little arrow on top of the d, we know, oh, it's a vector, direction's important. So distance is the total length or path taken to get from one point to another, and it is a scalar quantity. For instance, when I get into my car and I drive, the speedometer starts counting how many kilometers, and if I say drive to the school and I drive home, it's going to have a total of 2.5 kilometers to school, 2.5 kilometers all the way back. The total distance is going to be 5 kilometers. Displacement is the direct length between the final and the initial positions. It's how far you are from your starting point. It is a vector quantity, so we need to have direction. So if I gave you the exact same problem where I drove 2.5 kilometers north to the school and then I went 2.5 kilometers south to get back home, my total displacement is actually 0 because, well, how far am I from where I started? I'm 0. I'm 0 kilometers from where I started. So distance and displacement can actually give you different numbers. The big thing to remember is distance. There's no direction. All I care about is the total number of kilometers or the total path I've taken. Displacement, I do care about direction. And it's how far I am from your original position. So where did I start? Where did I finish? Finally, we have these two other formulas. One is speed and the other one's velocity. They both use the symbol v, except velocity, direction is important to us. It's a vector quantity, and we have this little half arrow thing above it. The formula is the same for both of them. It's always v is equal to d over t. V is equal to d over t. So v is equal to the distance divided by the time. That's our formula for speed. It's a scalar quantity. For velocity, velocity is displacement divided by time, and it's a vector quantity. We're now going to apply everything we've learned together into one question. It says, James walks 10 meters north and turns around and walks 8 meters south in 5 seconds. The first thing you do whenever you solve any physics problem is write down the given information. So I know that his first displacement, and it is a displacement because there's a direction there, is equal to 10 meters north. Then he turns around and he walks 8 meters south. So that's my second displacement. And the time is 5 seconds. And the very first question, I'm looking for the total distance. So distance, total, question mark. So now what we're going to do is just add them up. So my total distance is equal to my first distance plus my second distance, which would simply be just 10 plus 8, and that gives me 18 meters. Now we want to figure out the total displacement. So we're looking for the displacement. There's two different ways to do this. One way is just to simply draw it out. I'm going to travel first north. So if I start down here, if I go north 10, and then I turn around and go south 8, what I'm interested in is how far am I from where I started? Well, all I would do is go 10 minus 8 is 2 meters. And if I started down here and I finished up here, 2 meters north. And that's a great way to do it. There is a second way to do it, and I'm going to try that now. The other way is to use the formula. So my total displacement is equal to my first displacement plus my second displacement. My first displacement was 10 meters north. And my second one was 8 meters south. There's a problem here. You can't add directions that are pointing in different ways. Okay, so they either have to be both north or both south. And in physics, there's a really easy way to accomplish this. To change this to a north simply means to turn around. So all we have to do is make this negative. So it becomes 10 meters north minus 8 meters north. When you make a direction negative, you simply just flip it around. And now it becomes 10 minus 8 is 2. So 2 meters north. So if you want to solve it this way, where you simply just draw it, so 10 meters north, 8 meters south, I'm 2 meters from where I started, or the other method is simply just change the sign to negative, and then that way they match up. Part C says to calculate the speed. So the symbol for speed is simply just v. Our formula for speed, it's the total distance divided by the total time. Well, we already calculated the total distance way up here, and the total distance was 18 meters, and I know my time is 5 seconds. So all you would do is go 18 divided by 5, and that gives me 3.6, and the units would be meters over seconds, so meters per second. When we look at D part is similar. Okay, D is asking for the velocity. Well, velocity is equal to the displacement divided by time. So it's still d over t. We need the displacement, which we've already calculated as well. The displacement was 2 meters north. So I'm going to put that in. So it's going to be 2. The time is still 5. 2 divided by 5 is 0.4 meters per second. And we need to have our direction, which is north. If you forget the direction, it's actually wrong, so you have to put the direction in.